Hey there, in this video we're talking about variables and identifiers in C++. This covers sections 2.4 to 2.5 in the Gaddis C++ book. So variables, locations where you store data, where you store numbers, and identifiers are talking about the names that we choose to give our variables. So a very important topic here in chapter 2 of our C++ book. Okay, so you're using variables. You need to store data in the main memory, right? And main memory is a bunch of bytes, and the bytes have addresses that we talked about in the very first lecture. But fortunately, a high-level programming language takes care of those details for us by allowing us to use what looks like variables to us. So if you're going to do that, the very first thing you need to do, usually the very first line of program, is to declare the variables that you're going to use to store data. So that looks like this, right? It's two words. It's a type followed by a name that we give it. The type, there's a fairly limited number of options in C++ for that. The name, we can make up basically whatever we want. So variables represent data storage locations in memory. When you make this declaration, the C++ compiler is set to go find a currently unused slice of the main memory, and it's going to use that to store the number or some other kind of data later on. The type is a predefined C++ data type. So a couple things we've seen before. We've seen int for a variable where you want to store integer values. Remember, integers, no fractions, no decimals. Could be positive, could be negative though, could be 0, right? And there's also float or double types, and we've seen that at least once before. Those are for real numbers, anything on the real number line that gets represented by decimals, okay? So I think the example we've seen before is using double when it had to be money, including dollars and cents, is what we're going to do at least in this class. Now, the name, the second thing, is a proper C++ identifier. And it should clearly and accurately describe the data being stored. More or less, it can be anything we want it to be. There's a couple rules around that we'll see in a minute or two. But granted that you have your choice of what to name it, try to name it something in English that very clearly would state to other programmers what the point of this thing is. Here's an example. So a variable declaration that says int vacation days. So this is legitimate and I think well done. So the type here is int, right? This is reserving space for an integer value in the random access memory. It is clearly named, right? Vacation days, anybody can read that and say, oh, here's the number for the vacation days that apparently this employee has earned to this point. Conventionally, this is done at the top of your function, the top of the main function. Like in the C language, that's required. You've got to have all your declarations the very first thing in the function. In C++, you could put it in other places, but conventionally we put it at the top of the function so that the reader knows what variables are going to be in play in this slice of code. Now, int, float, and double, they're not the only options, but we'll talk about the other options for data types in the next lecture, actually. Now, once you have your variables declared, what are you going to do with them? You need to actually store numbers in those locations, and that's called variable assignment. Here's what that looks like. You're going to see a variable, an equal sign, and then some kind of number or mathematical expression on the right. So to be clear, the equal sign is being used to set a variable to a particular value. It might be changing it, as a matter of fact. I mean, variables vary. That's what that means. So you've got to use this particular format. You can't swap the two sides. The variable, you're going to have one variable that's going to be isolated all by itself on the left. And the technical name for that is the L value, the left-hand value, obviously. Now, on the right, that expression, it could be a single number. It could be an expression with mathematical operators involved, like plus, minus, times, divide, right? That's called technically the R value, the thing on the right. Now, what happens when the program actually runs is the thing on the right is inspected first, and if there needs to be calculations involved, it does that, comes up with a number, and then secondly, stores that result in the variable that's on the left. So kind of be careful about that ordering. It might not be exactly what you expected to begin with, but that's what happens. For example, if there's a piece of code that says bonus equals 2 times pay, semicolon, bonus and pay are variables that were declared previously. What that's going to do is it's going to look at the 2 times pay first. It's going to look in main memory at the pay location, load that number into the CPU, then it's going to multiply that by 2. And when that's done, it's going to take the result and it's going to store that product in the main memory in the variable that's called bonus. So right-hand thing happens first, and then it gets stored in the variable that's sitting on the left. Now, I should point this out, right? The equal sign here being used for assignment is being used in a different way than normal mathematics, right? Normal mathematics equals is an assertion that this on the left is the same as the thing on the right. This is a little bit different because this is actually changing what's in the variable. Find out what's on the right and then change the left-hand side to match is what's happening. So a little bit different. If I had been designing a language, honestly, I wouldn't have used this exact same symbol. There are languages, like I can think of Pascal, that use different symbols for this, and as a math person, I kind of appreciate that because I think it's easy to get confused about what's happening here. But hopefully you'll get accustomed to this. You won't be too surprised by it. The single equal sign means you're changing the variable on the left. You know, there's some other stuff like you're seeing, you know, like with bonus and pay, you're seeing we do use whole words for our variables in computing, and that's different, whereas in math, you'd probably use a single letter. We recommend not doing that in computing because we have the opportunity to use a full name, which is more expressive and more meaningful for human beings reading the code. So a couple of kind of, it's, you know, in large part, our writing is very similar to math, but there's a couple little details that are a little bit different in these C-based languages. So do be careful of that. Okay, now you can do both of these things at once, actually, in that when you make a variable, you can give it a number to begin with, and that's called variable initialization, which is on a technical level a little bit different, but probably won't look it to you. So initializing means to assign a value to a variable at the same time it is declared. And technically, that number is going to be sitting in the variable before the program even runs, as a matter of fact. So it's going to technically save a little bit of time. That also uses the equal sign. So you could have a statement that looks like this: int length equals 12. And the very first second that that program is running, the variable already has a 12 in it. Now, here's a major thing that you need to be cautious about, is if you forget to do that, right? If you forget to do that, if your variables are not initialized, then they're going to start off holding random garbage, or what I call random garbage values. Could be anything. You know, the variable is a place in memory, right? It's a bunch of bits, it's a bunch of switches. Maybe those switches previously got used for something else by another program, right? And the program ended, and those switches, those, you know, 0, 1, 1 zeros are still set up the way they used to be. And when your program goes and reuses that space for a variable, that data is still sitting there. So if you declare a variable, forget to initialize it, and then use it in some math later, use it in some multiplying or adding, you're going to have these crazy results because of the uninitialized data that you didn't know about that's sitting there. So the solution to that problem is initialize your data. Make sure that there's information in your variable before you go to actually print it out or use it. Let's actually test that, okay? Let's make sure we understand what I'm saying there. So I've made a very short little program here to test it. It's called no_init_var for non-initialized variables, right? And here I'm looking at the main function, very simple. I'm declaring 3 variables. You can declare more than one variable on a line separated by commas like this. So on line 13, I'm declaring 3 integer variables. I called them x, y, z. That actually isn't really the best names. We'll talk about that later, but good enough for now. And I'm not doing anything to them. I'm not initializing them. I'm not doing a sin statement, right? I'm not assigning anything to them, which is normally a mistake. And then on line 14, I'm going to print out the values are x, y, and z separated by some spaces. So if I compile this and I run it, let's see what x, y, and z are. So what I got here is the values are 0, 16, and 0. So the x is 0, and the y is 16, and the z is 0. Why is the y 16? Well, I don't know. Like I say, that memory location must have been used by something else in the past, and the bits are set up in the number 16 right now. There is no way I could have guessed that in advance, right? So if you are using uninitialized data, right, you're gonna be surprised by what's sitting there. If I were to run this program later on, like in an hour or two, those values would probably be different, right? Because other programs they used the bits in some different way. If you take this program and run it on your computer at home, I bet you're gonna get different values because you don't know. So that's why I refer to that as random garbage, and it's probably the number one thing you need to be cautious about when you start using variables. Make sure it's initialized before you use it in your processing phase. Okay, back to the slides here. Now, there's the idea of constants, right? Variables mean things that can change. So when we talk about variables, they're a memory location where you can save a number, and then you can save another number. It's going to set the bits up differently, right? It's going to overwrite the initial number, and you'll be saving some other thing. So variables vary. They can change from moment to moment in a program. If I'm running paychecks for multiple people, then the result of the pay will be one thing for a person and then different. Now, there are some values that shouldn't change, and in C++ or any of these languages, we mark those as constants. And it looks like this. There's a keyword const, C-O-N-S-T for constant. Exact same thing in, again, C, C++, or Java. And then you'd put down the type, which could be int or double or something else. You're going to make up a name, and normally we write that as all upper caps to indicate that this is a constant. And then you see equals and the number that should be the value for the constant. Okay, so we use this for data whose contents cannot be changed, right? It's one fixed number. It'll never change while the program is running. And the advantages to this are that it makes certain magic numbers easy to identify. If there's some number that gets used in a whole bunch of places in your code, we prefer to use names over numbers, right? Names are easier to read and for human beings to remember. So generally speaking, we would like to be using a name most of the time rather than actually some number that someone might not know. So if I am using the number 3.14 in the program lots and lots of times because I'm dealing with circles, right, it's probably a better idea to make a constant, right, a double constant because it's got a decimal in it, and actually call it pi, capital P-I, would be more informative to the reader about exactly what's happening in these slices of code. Now, the other advantage is if the program needs future modification. Like for some example, I've got a constant, and later on, months from now, the value changes, and I'm going to have to recompile the program, obviously. I'm only going to have to make the change in one place where the constant got defined, right? Whereas if I'd written the number, I'd have to go hunt for the number all through the code file and change it in a bunch of places. Okay, so we're thinking in ahead about what happens in the future if the whole program has to change. Notice the naming convention is for constants. We make them all uppercase, right? All capital letters. And if you have multiple words in the phrase, then we separate them with underscores. And we do that again as a styling thing so that just visually you can immediately see whether this identifier is a normal variable because it's all lowercase or a constant because it's all uppercase, right? So here's an example of that. I could be working on some kind of business program and I would make a const double because it's got decimals for money and call it sales tax percent, right? All uppercase, separate the words with underscores, and I've set that to the number 8.875. Now, for what it's worth, that is the sales tax rate in New York City. It's 8.875%. So, and if you also think about, working on a team, right? Not just a solo program, working on a team. If there were a coworker that went and accidentally overwrote that number, right? If it was a variable and they could change it, and by accident in the program, it changed that number. Well, now our program would actually be in violation of the law because the New York City tax code says that it's got to be, this number and not something else. On the other hand, if you go forward like 10 years or so and the law actually changes and this number becomes 10% or something, then there'll only be one single line in the code that we have to go change here, and I don't have to spot 100 instances of 8.875 to go change, right? You can just change it in one place if 10 years from now that gets altered by the law. So for things that don't have to change in a particular program run, make them constants, right? Easy to read, easy to maintain like this, a really good principle. Now, one thing we should talk about is we've been saying so far that all the code we write is inside the main function, right? Here's the first exception that might possibly happen. You're allowed to declare variables in C++. You're allowed to declare variables and constants outside the main function before it gets started. And that variable or constant would then be available for all the functions in the whole program. That's called global data. right? It's outside of functions, global to the whole program. That would be data declared outside any function, so they have scope or access through the entire program. Now, traditionally, C and C++ permitted this for both variables and constants. But it's been found that doing global variables is super dangerous. Super dangerous. If there's a variable and you can change it anywhere, it's incredibly easy to forget about that and on your team have some teammate accidentally overwrite it when you don't want to. So nobody makes global variables anymore in C++. But sometimes we do make global constants, right? That's considered acceptable because the risk of somebody overwriting it just isn't there. You can't change a constant. So it is pretty common that you'll be making global constants pretty near the top of your program file before the main function. And you're going to see that in all the examples, and you're going to see that in all the lab code for our class, actually. Okay, so globals outside the main function, fine for constants. Nobody does it for variables. Do not do that. It's too dangerous. Okay, now the names that you give your variables and your constants, those are called identifiers, and you can mostly make up what you want. C++ does have a couple rules for how you make your identifiers in order for C++ for the compiler to know, hey, that's supposed to be an identifier, just for starters. So an identifier is any programmer-defined, programmer-created name for a new variable or a constant or a function or a bunch of other stuff that'll come in later courses probably. Okay, and that's certain syntax rules that got to be followed or the identifier cannot be compiled because the compiler won't realize that you meant it as an identifier. And here's the fairly limited number of rules. The first character of the identifier must be alphabetic or an underscore. It's going to be a letter or an underscore. It cannot be a digit, cannot be a number. Now, the other symbols in the identifier can be letters, can be alphabetic letters. They can be numeric digits, not the first one, but the later ones, or underscores. No other symbols are allowed. So you can't use punctuation, no hashtag, no @ symbol, no question mark, right? It's just letters and digits and underscores, and the first one cannot be a digit. You cannot match any C++ keyword. So all the keywords that are built into C++, like int and float and return and things like that, they've already been used. So if you try to make an identifier variable using those, that'll be rejected. Keep in mind that identifiers are case sensitive, right? The case matters. Uppercase is considered different from lowercase. So if you're new to programming, you have to be really, really careful that once you make a variable that starts lowercase, you've got to keep it exactly like that forever, or the compiler will think you're talking about two different identifiers. So for example, rate starting lowercase and rate starting uppercase would be two different variables. Two different variables as far as the compiler is concerned. So if you declare lowercase r rate, right, and later on you try to print out capital R rate, the compiler is going to give you a syntax error and say, you never declared that variable. Capital R rate, I don't know what that is. This is not a C++ program because you didn't declare that variable. So you'd have to go fix that and make sure that you're spelling it the right way every time. So those are the only rules that C++ cares about, right? Those are the only rules the compiler needs to realize that something is an identifier. But on top of that, for the human being angle, there's a bunch of identifier conventions that people use to make our variables easy to read again, which is outside anything that the compiler cares about. So this here is the human being perspective. So in addition to the compiler rules, right, C++ programmers follow certain conventions. The point here is to make it easy for other programmers to read. And we would be thinking about things like this. The identifiers should be descriptive, right? They should be clear, they should be descriptive, they should be English words or phrases that describe the specific thing being stored, right? So my little example previously of X and Y and Z, that's actually not super good, right? Those weren't English words. So in a real program, we would want to use something different. Spend some time thinking up good, clear identifiers. This might not seem like a big issue to begin with, because the compiler, the computer doesn't care about it. But honestly, when I'm programming, I find I probably spend more time thinking about good, clear identifiers than anything else. Because if this program is going to last for months or years and other people are going to look at it, I really want to lay the groundwork for it to be really easy to understand for me in a year when I'm no longer thinking about the same stuff, or other people that are going to share in this. So I spend a couple minutes. Sometimes I look up in a thesaurus, like what is the exact best English word to describe this thing that I'm trying to handle in my program. So spend a little bit of time coming up with clear identifiers, and you'll find it will make your work a lot easier in the weeks that come later, right? Make sure that your identifiers say what they do and do what they say, right? If you name an identifier one thing and you put a totally different number in it, that's going to be super confusing for human beings, right? I mean, the compiler is going to run with it, it's going to do it, but if the variable says it's something, make sure that that's actually what's being stored in the variable. So I usually phrase that as the variable should say what they do and do what they say, and not something else. Okay, as far as the spelling goes, we frequently type our identifiers in what's called camel case. It's a common way of spelling our identifiers. And what you do for that with a variable is you start with a lowercase letter, right? Start lowercase. If you have a phrase with multiple words in it, we capitalize the first letter of each of the subsequent words. We generally avoid numeric digits, and we generally avoid the underscores that C++ permits, but in my experience, most people don't do that anymore. There was a time in the past when most identifiers were written with underscores, but I think that time is no longer the case, and I see most people writing their variables in camel case like this. And in this example, you can see why it's called camel case, because of the later capitals, there's going to be a hump in the middle of the word. So victory points is a good identifier. It's a clear English phrase, right? It's clearly the number of victory points that someone has earned in a game. Starts with lowercase v, right? The word P starts with a capital P. That's why there's kind of a hump in there. And it's very easy to read on the screen. There's no underscores, there's no digits. And I would call that a good identifier under the camel case system. So that's what you're going to be seeing in all the examples in the book and all the examples that I write. Let me quiz you on that. So here are some suggested identifiers for a variable. Now remember, there's two things we talked about. We talked about the rules of C++, about whether the compiler would accept it or not. And the second thing, from the human being perspective, the styling of the convention for what's easy to read for human beings. So I'm going to quiz you separately on this. First of all, I'm asking the question, does this compile? So I'm going to do the first one, right? The identifier T. Does this compile? Yes, right? You saw me compile a program earlier that has variables X, Y, and Z, so that's permissible. It starts with a letter, right? It doesn't start with a digit. There's no weird symbols in it. That is compilable by C++. Okay. Now, I might recommend maybe you pause the video, right? And you see if you can answer the other possible identifiers in the list here. Does this compile? Maybe write it down. And once you think you have an answer to those, restart the video and see if you agree with me. Okay, so assuming that you have your answers to the rest of them, let's see if these other ones compile. Total cell, no, because there's a space in it. You can't have spaces in variable names. To the compiler, that's going to look like two different variable names. So that's not a variable name. Next one, no, because the $sign. Weird symbols are not allowed. This one here, yes, it's all letters. That's permissible. That'll compile, right? This one will compile because it does permit underscores like that, right? And so will this, it's all letters, and so will this, it's all letters. So that's perfectly fine. Now, the second issue, again, is that a good variable name under our convention that human being programmers usually use? So I'll look at the first one. I would say no. Definitely do not use single letters for a variable name. It should be a full English word or a full English phrase that clearly describes what is being stored in this location. So no to that. So again, maybe pause this video and in your head or on a piece of paper, answer what you think the rest of that list is for, is this a good variable name under our conventions we talked about before? Okay, so assuming you have answers to that, let's see if these are good variables. Now, obviously, if it doesn't compile, that's no good at all. You literally can't use that. So no to this and no to this. Next one, it'll compile, but I would say no because it's not camel case, right? since it's all lowercase, those words kind of all mashed together. It's kind of hard to read. Not camel case. This one here, a little bit more readable, and once upon a time, that would be a good variable name, but most of us don't use underscores anymore for variable names. Remember, we do that for constants, right? The constants, since they're all uppercase, your separator does use the underscore, but not for variable names anymore. Next one, no, because that starts with a capital letter. We actually reserve capital letter names for what are called classes that will happen in programming 2, actually. So that isn't permissible for human beings. This last one is the one you'd want to use, right? That's actually a camel case. It starts lowercase, the word sale, there's your uppercase letter, there's no underscores, there's no digits in it. That's actually the only good name on this slide. So when you're making your variable names, make sure you put them in camel case, like that last example, total sale. That's a good name. Okay, so that is our lecture on variables and identifiers, right? And at this point in our in-person class, we would probably do lab 2.2, in which you get to practice using constants and variables like we're talking about, and also using arithmetic operators, plus or minus or times or divide, probably in an assignment statement, right? You have an assignment statement, does some arithmetic, an equal sign, store it in a variable. So this is a pretty good lab for that. And if you do have access to the lab manual, you can try that on your own. Notice in phase 2 that I am asking my students to write a test script, right? The goal of this program is to compute the circumference and area of a circle, specifically with radius 5.4. So what I would ask my students to do is on a piece of paper, if the radius of the circle is 5.4, what should the circumference output be, and what should the area of the output be? And we would do that before we write any code, right? Later on, when we write the code and compile it and test it, we're going to use that to confirm that the output from our program is actually correct. So pretty good lab there. What we haven't done is we haven't talked about the other data types, right? We've only talked about the int type and the double type so far. So there are more basic data types in C++. That's what we got to talk about next time when we talk about the basic data types in C++. And remember, it's the same as C or Java or other classes. So that's an important lecture next time. I'll see you then for that.